All right, today we're diving into a research protocol that is, frankly, mind-bending. It asks this really wild question. What if we could build a whole new language to talk directly with the world around us? And I don't just mean with other people, I mean with plants, with the air, even with our own bodies. Let's get into it. Okay, so to get our heads around this, the researchers start with an idea that's both ancient and, super futuristic. They point out that for basically all of human history, cultures have used things like song lines or mantras. And these weren't just symbolic, they were seen as actual, functional tools or operative interfaces for interacting with the world. This project is really about trying to connect that ancient wisdom with cutting-edge science. And that brings us right to the core question that they're asking, which honestly sets the stage for this entire experiment. I mean, think about it. We already have systems that control our environment, right? Your thermostat is a control system. It reads a number, it executes a command. Simple. But what they're going for here is so much deeper. Instead of just a one-way street of orders, they want to create a real two-way dialogue, a language that has meaning, that's expressive, and that can somehow be understood by us humans and the biological world. So, if you're going to go and create a new language to speak with nature, I mean, where do you even start? What does that alphabet even look like? Well, the researchers came up with this idea they call wave grammar, and the insight here is just brilliant. They're not inventing something totally from scratch. They're actually borrowing a universal algorithm that nature already uses everywhere. You see it in ocean waves, in brain waves, you name it. So the basic building blocks of this language, these word waves, are designed to speak in a way that nature already understands. And this slide just lays it out perfectly. Every word wave has three parts. First, you've got the carrier. That's the fast vibration, like a musical tone. Then you have the envelope, which is a slower rhythm that kind of holds that carrier wave. A good way to think of it is like the pace of your own breathing. And finally, there's the boundary. That's the medium, like light or air or humidity, that gives the whole pattern its shape. So word isn't just about what it means in your head. A word is about what it physically does. Okay, so now that we have a grammar and an alphabet, we need some kind of machine that can actually speak this language. And this is key, it also has to be able to listen for a reply. And here it is. Say hello to the tricorder transductor. This thing is the absolute heart of the whole experiment. It acts as both a speaker and a microphone for this new language. It listens to a person's voice and then translates it into a really complex, multi-sensory word wave, a mix of sound, light, humidity, and vibration. And then it measures the response from the human, from the plants, and from the air itself. And this is where all those abstract ideas suddenly get very, very real. We're looking at the first 5 words in this new lexicon. Just take the word moo, for example. The intent is calm or opening. So how is it spoken? Well, it's a 40 hertz hum, plus warm light, plus a gentle airflow. Or look at newer for sleep. That one's a soft 432 hertz tone, some dim infrared light, and even the scent of lavender. It's a truly multi-sensory language. But of course, talking a new language is pretty pointless if you have no idea whether you're actually being heard or understood. So how do you know if any of this is actually working? This is the huge scientific challenge, right? How do you create a scorecard? How do you track whether this communication is having any kind of positive effect? How do you score a conversation with a plant? Well, the researchers came up with this composite score they call the Fractal Coupling Index, or FCI. And it's a really clever way to measure success because it pulls in data from all over the place. It looks for an increase in human calm, better air quality, better plant health, and it even subtracts points if the plant shows signs of stress. So a higher score literally means you're having a more harmonious, a better conversation. And they're not just theorizing about this stuff. They are putting this language to the test with 2 really different experiments. First, there's a 14-day pilot where a person just tests the calm and sleep words at home. But then there's a much bigger 90-day trial in a public micropark to see if these word waves can actually improve the health of a whole tiny ecosystem. So, where does all of this lead? What's the end game? Because the goal here isn't just to write a cool research paper. It's really about imagining a totally different kind of future. I mean, if this works, the possibilities could really shift our relationship with technology and nature. Imagine tools that help you relax or focus, not with some app, but through a direct conversation with your environment. Or think about little automated routines that gently make urban gardens healthier. It could even lead to these incredible living language kits for kids in school to explore biology in a totally new way.
So, yeah, here's the crucial point. This project is trying to do more than just collect data. The ultimate goal, the real dream, is to take a scientific experiment and translate it back into something meaningful we can do every day. A new kind of ritual for our well being that's grounded in both ancient ideas and modern science.
And that leaves us with a really fascinating question to just chew on. If you could actually speak to the world around you, to your houseplant, to the air in your room, to the garden outside, and you knew you were being understood, what would be the first thing you'd say?